All right, in this video, I'm going to go over how to solve radical equations. And we're going to do this first one here at the top, but just to take a look at these steps real quick, we'll be following these steps in every single problem. Obviously, there'll be like different variations of these, but you'll start to get the hang of it. Biggest thing is to isolate the radical if you only have one. If you have more than one, then isolate one of them on one side of the equation. And then we'll get into where you have more than one, and it could be a little bit tricky. The one in this video is going to be pretty straightforward, but in class I can show you some more challenging ones, okay? All right, so let's do this first one. It says to solve this following equation and then check the answers. Always want to check with these because you're going to get some answers that may not actually work, right? We've used that term before in our rational equations. Those are called extraneous solutions. So I'm going to isolate this radical by moving it over to the other side to get x equals the square root of 4x plus 12. Then I'm going to raise both sides to the second power, which will get rid of that square root. Remember, there is a little index of 2 here, so you're always going to raise each side to that index to get rid of it. All right, so this will be x squared. And then because those are inverses of each other, I'm just going to write 4x plus 12, and you'll notice the radical is now gone. Now, this is a quadratic equation, all right, with that x squared term. So I'm going to get everything to one side. And so I can set it to equal to 0, which allows me to factor. So I have x and x. So I need factors of negative 12 that add to negative 4. So I'm going to use negative 6 and positive 2. So my two answers are x equals 6 or x equals negative 2. Now I'm going to check these, right, to make sure they both work. I'll start with 6. So 6 minus the square root of 4 times 6 plus 12, and that whole thing should be 0. So in the radical, that's going to be 24 plus 12, which is 36. So 6 minus 6 is 0. That works. So this one definitely works. Let's check negative 2. Negative 2 minus 4 times negative 2 plus 12 equals 0. So negative 2 minus, that will be negative 8 plus 12, which is 4. So negative 2 minus the square root of 4, which is 2, equal to 0. Now, unfortunately, negative 2 minus 2 is actually negative 4, which is not true. So this doesn't work. So because it doesn't work, this one is not going to work, right? This is our extraneous solution. Now, there might be some times where you have more than one extraneous solution, you have no extraneous solutions. You just have to always check to make sure that, everything actually works. Okay, let's do a bunch more. All right, so here I'm going to move this this 9 to the other side with subtraction to isolate the radical. All right, once I've isolated it, I can take both sides and raise them to the second power. That will get rid of the radical on the left side, and 7 squared is 49. Moving the 1 over with subtraction gives me 48, so x is equal to 8. Always check it. Square root of 6 times 8 plus 1 plus 9 equals 16. So that's going to be 48 plus 1 is 49. That's 7 plus 9 is 16. That is correct. So 8 works. Let's do letter B. All right, moving the 6 over with subtraction, I have the square root of 2/3 x equals 2. I'm going to raise both sides to the second power, which gives me 2/3 x equals 4. I want to get rid of that fraction in front by multiplying both sides by the reciprocal. So now we have just x on the left side and 4 times 3 halves. You can think of it two ways. You could do 4 times 3 divided by 2, or you can actually look diagonally and do 4 divided by 2 first and then times 3. Either way, you should get 6. Let's check it. 2/3 times 6 plus 6 equals 8. So 2/3 times 6, that's going to be 4. The square root of 4 is 2, and 2 plus 6 is 8. That does work. So does 6. Okay, this next one is the only one here that we're going to practice where you have two radicals. Now, because they're set equal to each other, I'm going to go ahead and just square both sides. And when I do that, both radicals go away. All right, and then it becomes a linear equation like you did in Algebra 1. Move the 3x over to get 2x. Move the minus 7 over with addition to get 10. So x is 5. Let's confirm this works. Oops, not plus, that's minus. This one is going to be the addition. Okay, so this will be 25 minus 7 is the square root of 18. 15 plus 3 is also the square root of 18. If you wanted to reduce it, you could. No reason to, right? Just want to make sure that they are the same, which they are. So 5 works. Okay, let's isolate this radical, but you'll notice that we do have our first index that is not a square root, so that's nice. So I'm going to move over the 13 first. When you're doing these, make sure you undo these things with the inverse order of operations, right? So if this is order of operations, you would multiply the 4 times that cube root and then subtract. But we want to undo things going backwards. So move the minus 13 over with addition to get 16 here. Then I'll divide both sides by that 4, which will give me the cube root of x minus 5 equals 4. I want to get rid of this cube root by raising it both sides to the 3rd power. So this will be x minus 5 equals 4 cubed, which is 64. So adding that 5 over gives me x equals 69. Let's check it. So plugging in 69 for x, I'm hoping this is a true statement. That's going to be the cube root of 64. The cube root of 64 is 4. And then 4 times 4 is 16. 16 minus 13 is equal to 3. So this does work. So 69 is an answer that is correct. All right, let's do 2 more. All right, these both here, E and F, both have what are called rational exponents. All right, and the way you want to deal with this is first you're going to isolate it, right? And both of these are isolated, but like in E, if I had an x to the 3/2 power and then like separately from that minus 6, I would move the minus 6 to the other side first. You still want to isolate. But now I'm going to write it a little bit bigger. It's easier. The way you want to get rid of that power is you want to raise both sides to the reciprocal of it, right? Because if you remember in our exponent rules, when you do a power raised to another power, we multiply. And if you multiply 3/2 times 2/3, you get x to the 1st power. Now you don't need to write the 1, but just showing you why we do that. All right, so now I'm going to write this as 216 to the 2/3 power. Now, like we did in our first notes in 35, I'm going to write the 216, write the radical symbol. The denominator is the index, and the numerator is what it's raised to. Now, you may not know the cube root of 216 off the top of your head. You might know it, but you could probably figure this out, right? 6 times 6 is 36, and 36 times 6 is 216. So this is 6, but then we do need to square it, which will give us 36. So let's check it, make sure that works. So 36 to the 3/2 power, that would be the square root of 36 cubed, has to be equal to 216. And we said the square root of 36 is 6, and 6 cubed is 216. So this does work. Okay, last one. So we have x plus 7 raised to the 2/5 power. I'll write it again, just so I have room. So to get rid of that power, I'm going to raise both sides to the reciprocal, which is 5/2. So that's going to be x plus 7, right, to the 1st power, so I don't need to write anything else. And then this is 4 to the 5/2 power. Let's go ahead and write that with a radical. So that's the square root of 4 to the 5th power. So x plus 7 equals, the square root of 4 is 2. And I'm going to raise that to the 5th power to get 32. And moving that 7 over with subtraction gives me x equals 25. Let's make sure that works. 25 plus 7 to the 2/5 power has to be equal to 4. So that's 32 to the 2/5 power. Writing that radical with a 5 as the index, and then I'll square it. The 5th root of 32 is 2, and 2 squared is 4. So 25 does work. All right, I know I go very quickly on these. I totally get that, but watch it again, slow it down, speed it up, whatever you want. Come see us if you have any questions, and hopefully you saw to isolate first and then go from there. All right, good luck.